Hi and welcome back to another demo of the UK electrical simulator. In this video we're going to continue exploring the Megga Meter, but this time we will use its voltage measuring function on a load. At the moment there are three options available in voltage mode: AC, voltage drop and DC. Let's begin with a simple AC circuit. We'll start by adding a consumer unit, a C4 bus using a 16 amp RCBO, a socket load, and a Megga Meter. Set the Megga Meter to voltage mode, then release both probes. Next, wire the load back to the bus, L4 to L, N4 to N, and E4 to E. Now energize the circuit by pressing the C4 button, switch on the animation using the A button, and then turn the load on. On the circuit meter, we can see that the 500-watt load is drawing around 2.17 amps. Now drag probe 1A to the L terminal and probe 1B to the N terminal. When the probes are connected correctly, the LEDs on both probes will turn green. You will now see 230 volts displayed on the meter. If we remove the probe from the L terminal, the reading will drop to 0. If we then move that probe back to another live point, such as L4 on the bus, the voltage reading will return. To keep the simulator simple and easy to follow, we have chosen to display a steady 230 volts whenever AC voltage is present on the circuit. In the real world, the measured voltage can vary depending on the installation and supply conditions, but for training purposes, we have kept that value fixed, so the behavior is easier to understand. Now let's move on to the voltage drop function. You can select voltage drop from the lower drop-down box on the Megga Meter. This allows you to test the voltage drop along a cable run and across a load. To measure voltage drop, connect the probes to the load in the same way as before, then press the test button. But before we do that, let's set up a more realistic example. First, double-click the bus terminal and change the bus from C4 16 amps to C1 40 amps RCBO. Then press the W button on the bus component and select the brown line wire. Leave the CSA at 2.5, but increase the length to 40 meters. Do the same for the blue neutral wire and the CPC earth conductor. So in effect, we are now supplying the load using a 40-meter run of 2.5mm twin and earth cable. Next, double-click the socket load and increase the power draw to 5 kilowatts. Make sure the circuit is energized and the socket is switched on, then press the test button on the Megga Meter. In this setup, the meter shows a voltage drop of 12.89 volts. If we now press the I button on the meter, a detailed information panel appears, showing the meter reading, the current draw, the wire lengths, the wire resistance, the voltage drop value, and the percentage voltage drop. Because this example fails the voltage drop test, the simulator also suggests a more suitable CSA cable size to use instead. That makes it a very useful training tool for understanding why conductor size matters in a real installation. Let's now change the line and neutral conductors to the suggested 4mm squared size and run the test again. Enable the selected wire option, make the required changes, and leave the CPC earth conductor at 1.5mm squared, which is correct for a 4mm twin and earth cable type. Now run the test again, press the I button, and review the updated results. This time, the voltage drop test passes. We will cover voltage drop, conductor sizing, and cable types in much more detail in a separate training video inside the simulator. For now, this is simply a quick demo to show that the Megga Meter includes a useful voltage drop function. The final voltage option on the Megga Meter is DC voltage. At the moment, in the domestic electrical simulator, DC voltage can be measured on a small number of components, including the AC to DC transformer and the DC lamp. More DC components are being added for training purposes, and there is also a wider range of DC equipment available in the off-grid electrical mode, but we'll leave that for another video. To demonstrate DC voltage, I'll quickly load a saved workspace. In this example, we have a 230-volt AC to 12-volt DC transformer, feeding a 12-volt DC lamp. We also have a Megga Meter already set to DC voltage mode. The two probes are connected across the DC lamp terminals, and we can clearly see 12 volts DC displayed on the meter. We can also see that the lamp is drawing around 250 milliamps from the transformer, shown above the clamp meter. We will return to the transformer and DC lamp again in a future training video, where we will use them to help explain AC to DC in more detail and explain series and parallel circuits. I hope you found this demo useful. Please like, subscribe, and leave a comment below. I'd really love to hear your thoughts, especially if you think this kind of tool could help support your training journey towards becoming a UK electrician.